Thank you, Antonio. Good afternoon, everybody. Yeah, my name is Daniel Pereira. I'm a sales manager for the market segment Semiconductor at Bühler Leibold Optics. And today I bring maybe a little bit of a different perspective from the aim of the meeting. Well, we are more enablers of thin film fabrication and characterization. And we today we show basically two examples of our sputtering technologies for applications in optical sensing and PICs. A little bit about Bühler first. So Leibold Optics is a part of Bühler, a Swiss company, and we are present all around the world. So we are machine manufacturers for all sorts of optical applications. We have three application centers, one in Germany, so where I'm coming from, one in the US in Raleigh, and one in China, in Beijing. In all of these application centers, we have machines from our portfolio where we can do basically application tests for our customers and do evaluations of machines and do product development and product innovation. We are a total of 650 employees worldwide as part of Leibold Optics. As part of Bühler, we're more than 10,000. And we have more than 3,000 systems installed worldwide for all sorts of applications, from which we develop 5% of our turnover is then invested back into innovation for new products, new developments, new services as well. Now, what exactly do we do? Yeah, we basically add functionality of different types of substrates via an optical coating. We work with applications in ophthalmics, we work applications in precision optics, in emerging applications in semiconductor. And basically, whenever our customer needs to do an optical coating, they come to us for our machines, and we can do that. So we work with all sorts of substrates, rigid substrates, thin substrates, or flexible, so on and so forth. And we aim to give basically more functionality to silicon or glass substrates, for example, for all sorts of applications. And here I actually have a key fact that also giving functionality via optical coating of an architectural glass can lead to reduction of energy via heating or cooling. So this is really not just for in terms of optics, there's the benefit, but also in terms of energy saving. So all sorts of applications regarding the interaction of the light with the substrate. We have machines for sputtering, evaporation. We have trimming machines. So our portfolio is rather extensive among this more than 3,000 systems we have installed. I come to you from the semiconductor market segment, which is a little smaller slice from the Leibold Optics portfolio. And in here is more about integrating optics with the semiconductor. So we try to bring the best of both worlds and bringing them together via integrating optical filters on semiconductor chips. And we can do that via sputtering tools, evaporation tools, or trimming tools. Our applications are listed here. We work a lot with 3D imaging and 3D sensing, which I will show you a little bit more in the coming slides. We talk about lighting and display, so filters for the display technology. Photonic integrated circuits, I will also explain a little bit more. We are also working RF technology, so in SAW filters, WAV filters, or wafer bonding. And we are recently also starting working more into R&D topics and more into evaporation for 3D coatings and so on and so forth. So you see here a little bit about our product portfolio, but today I will really focus on two main aspects: what we do in 3D imaging, 3D sensing, and what we are working on in terms of PICs. First of all, I would like to explain you a little bit about our sputtering technology, actually, and thank you to Philippe for already showing a little bit of our tool. This was a nice surprise. We have what we call the Helio series, which is a sputtering tool capable of producing the oxides and metals of some of the materials that were already mentioned today, actually. Our tool, and let me put the presenter here. Our tool is basically Second, yeah. So it's a turntable tool capable of doing sputtering of thin films of multiple substrates at a time, where you have a sputtering station and a plasma station. So if you think of sputtering of silicon, for example, and the plasma activation with oxygen, then that's how you form the oxide, and you form the silicon oxide that is common in the industry. So basically, the substrates are rotating along the turntable, meaning you are producing these films on multiple substrates at a time. You can use all sorts of sputter targets that could be possible, meaning naming, for example, silicon. Germanium was also mentioned. Nio was also mentioned. And you can use additional gases to make all of these all sorts of combinations, meaning, for example, silicon oxide, silicon nitride, silicon hydride. All of these are possible. In Leibold Optics and with the Bühler, with the Helios series, we actually focus on 4 different pillars of our technology. So we actually developed the technology. We have a well-proven system from the precision optics, and we are constantly developing it for a lot of applications. And now for semiconductor, we have a lot of an extensive knowledge in filter performance and filter manufacturing on substrate sizes even higher than 200 millimeters. So we're actually working also with 300 millimeter machines. And we have a high uniformity across these bigger substrates on complex filters. We work, because we also talk about semiconductor, we also think about developing filters for low particle performance. So we have here our statement to achieve number of particles sized 160 nanometers or more, so a number of particles below 100. And automation, also thinking a little bit about semiconductor to connect our tool to the fab is also something that we work on and we develop all within the Leibold Optics world. So this is a system that has been in the market for more than 20 years, and more recently in the semiconductor field. And just a little bit on the examples of potential applications we see for the 3D sensing. We talk about proximity sensing that uses filters in the visible region, and this can be done with filters on RGB. And these kind of filters are based on oxide materials, or can be based on oxide materials with niob and silicon. And basically working with the structure, you can build the filter with the different colors. Or if we're talking about applications like infrared cameras or facial recognition, then we're talking more about filters that are built and they build based on silicon hydride or silicon oxide, and with structures that can achieve performance in the infrared. So at Bühler, we developed these so they can be integrated into semiconductor fabrication. So really building these on top of chips. So this is our core in the semiconductor group. And our intention is to really integrate the machine into the semiconductor fabrication, and be that building the films on top of structured wafers, or building the films on that can be structured later on. And this is the highlight of this slide, where you see 2 different approaches where both can be where both our tool can be present on. And this was a little bit pointed out by Philippe during his talk. We also have an extensive collaboration with IMEC, where we develop processes. We try to understand particle generation, and we're really trying to bring together the tool into a state where the semiconductor market can also benefit from. So this is a very good extensive collaboration that we've had for a few years now. The next point that I have here is just a little bit of a teaser. We also have a collaboration with a company called Shinkon. Shinkon is a machine supplier from Japan. We have a collaboration with Shinkon in the way that we can promote the products from Shinkon in Europe. And Shinkon aims to revolutionize the photonics industry, and Bühler is helping in this revolutionization. Sorry. And how is this being done? So thinking a little bit about lithium niobate and photonic integrated circuits, there's a dependence on the industry of what is called these wafer bonded lithium niobate films that are used to all sorts of applications, namely in PICs. And actually, Shinkon is working on a sputtering technology that is capable of doing the epitaxial growth of lithium niobate on the various substrates, meaning growing lithium niobate on a film following the crystalline structure of the substrate or the film that is below it. So actually looking into applications of PICs, and working with materials such as lithium niobate, silicon nitride, or silicon oxide for such applications. And we are actually actively promoting this new technology because we think that we can really revolutionize this field. And we are looking for partners that are willing to discuss with us, talk to us more about the needs of their industry, of their markets. So if you are in this field and you are interested in learning a little bit more what we and Shinkon are doing, and are willing to cooperate, I'm very happy to discuss this further. And this is one of the reasons that we are here today presenting. So this will be my last slide. Thank you very much for your attention. If you have any questions, feel free to ask, or you can contact me at any time. Thank you very much.